Okay. Good evening. I'm Dr. Roshni Yehuda, and today we are here to talk about the IQ challenge in green interiors. We have been promoting the concept of green interiors, which involves a whole host of things like using the right kind of materials, having acoustics control, providing fire resistance, universal access, providing visual and thermal comfort, water conservation, energy efficiency, and last but not the least, indoor environment quality, which is what we are going to talk about today. And we have a guest on board with us who elaborate on some of the details. So indoor environment quality is our focus today. The rest of the things we will be talking in subsequent webinars. So let me just briefly tell you about this topic, that is indoor environment quality. This is a term which refers to environment quality within and also around buildings, because what is outside affects the inside. And then, depending on how you have designed your interiors, that can continue to remain, or it can be removed or something like that. So it is something that is related to your building and its surroundings, especially as it relates to the health and comfort of the occupants. And why is this important? Because we spend a lot of time indoors, whether it is in our home or it is our office. It is believed that people spend 90% of their time indoors, and the indoor air can be 2 to 5 times more polluted than outdoor air for reasons that I've just told you. And the concentration of contaminants can build up in an enclosed space. So this is what is the whole idea of sick building syndrome, which came to be known better in the 1970s. And then, people began to research as to why and what are the causes, and then began to address it. And now we have quite a few answers about why buildings become sick, or they cause their occupants to become sick. And of course, the various aspects of how it affects depends upon few things, such as the nature and potency of the toxins, the susceptibility of the person exposed. For example, not everybody gets seriously affected, but some people who may have, say, certain kind of susceptibilities like throat infections or something like that, may get easily affected. And of course, it depends upon how long you have been exposed, the magnitude and the duration of your exposure. So these are some of the scientific things that are involved when we talk about indoor environment quality and its effects on people's health. And there are various types of indoor air pollutants. When we talk about environment quality alone, we look at these ones, that is carbon dioxide, carbon monoxide, volatile organic compounds, and then we talk about suspended particulate matter. The ones which are really dangerous are the ones which are below 10 microns and below 2.5 microns. And then, there are also bioaerosols. In case you have some kind of a waste or something nearby, they get attached themselves to these suspended particulate matter, and then they can be quite dangerous, quite critically dangerous. And on the other hand, we also have thermal comfort, which affects the human comfort inside buildings. So that the aspects that are connected with that are humidity, that is relative humidity, the air temperature, and also the mean radiant temperature, which is dependent upon the kind of walls or the kind of surfaces that are there inside your building. We have done a lot of research in the past on indoor environment quality in offices. And in a typical office, you'll be surprised to know the different types of contaminants that exist. For example, we have VOCs, which come from industrial cleaning solvents. We use different types of cleaning solvents to clean our floors and various other equipment. And there are dust mites from curtains, which get attached to curtains and fabrics. There are VOCs, which are because of the adhesives used in carpets. VOCs from electronic equipments. There are fine particulate matter, which come from photocopiers and printers. There are biological contaminants from AC ducts. There is and a whole lot of other kind of things that are there in office spaces. So in just a small space like this, you can imagine the different kinds of indoor environment pollutants that exist and that can affect you. So there are international IEQ standards. So it's important that we maintain our indoor environment quality within these standards. And probably Abhinav will be pointing out more on this. And there are various ways in which it can be mitigated. And one of them is using plants. There have been a lot of research conducted in this area. Not only they are known to modulate temperature, humidity, but also they are able to absorb dust particulate, dust matter, and as also VOCs to a certain extent. And you can mitigate by using the right kind of materials, or having materials with low VOC finishes, providing natural ventilation, at least some way of degassing your space on a regular basis if it's continuously shut, and providing the right kind of filters and using the appropriate plants indoors. So today we have Abhinav Gupta, who's the CEO and co-founder of ActiveBuildings. Welcome, Abhinav. A company that helps build managers and occupants get complete control on how buildings are managed. He has a background in engineering and research and development. He does a lot of R&D, and I'm very proud of him because I had met him some years ago when he was providing us these instruments for measuring the indoor environment quality. And a lot of my students did research using the instruments that he provided. And now he has this company which works worldwide, not only it's based in Mumbai, but has worked in Singapore, Switzerland, and Bangalore. So really nice to have you on board, Abhinav. So he is going to talk to us about how to ensure good indoor environment quality indoors, and also how can we design better spaces. So over to you, Abhinav.
Thank you so much, Dr. Roshni, and it's likewise been a pleasure for me. When we started out, I think first we met in 2017. When we started out, we were just thinking of what can we do with air quality, and your programs was one of the few programs that was not just taking air quality into picture, but also light, acoustics, as you mentioned, also greenery, the presence of the right kind of materials, and it for us, it's been an inspiration from that point onwards, not just to measure air quality, but also to see what can be done with air quality, what can be measured. Specifically, I think you mentioned about VOCs. We have seen, as you pointed out, we've seen many places that have, experienced this very harsh smell that comes from the VOCs, and they want to like deal with it, and some of those things that you mentioned, that's exactly how we would also approach these things. It's just that our approach comes with a lot of data. So what we have done, us not being experts in the building industry, we've learned from professionals that have guided us, but our guiding light has always been the data. So I'm going to speak a little bit about what we have today as data on our office. We've taken our office as an example, and we're going to talk a little bit about not just VOCs, some of the standards you mentioned, and also how we can get the get the natural ventilation inside. So I'll just share my screen that I have.
Just a second. Yeah, you can do that.
So okay. So today's topic of discussion is how can we pilot the ActiveBuildings IQ systems in different ways. But basically what we're going to talk about is how can you achieve the air quality that's mentioned at the bottom half of the screen. PM 2.5, less than 5 micrograms per meter cube, PM 10, all of these excellent air quality parameters. Is it possible to achieve? What kind of design decisions can we take? How can these decisions be informed by data? And how can you use data not just of indoors but also of the outdoor pollution to decide not just what kind of solutions I want, but how frequently do I need to change the filters? What kind of filtration do I need? Do I need to invest in a heavy duty filtration, or is just a little bit of filtration enough? So to give you some context, our office is set up right in the heart of Andheri East industrial estate areas. So you have some industrial estates in here in Marol. We are very close to the industrial estate that is in Sakinaka, near Khairani Road, and there are a lot of factories around us. We ourselves are an industrial estate setup. The outdoor pollution is extremely high. So therefore, you have to close your windows. There is no way you can keep your windows open because you don't want to breathe in all of that bad PM 2.5, bad PM 10, and bad chemicals in general. You also want to make sure that the number of people that are inside, they're not suffocating just because they're breathing in the AC air. And contrary to popular belief, split ACs and VRV ACs are not really bringing fresh air. They're just recirculating the air inside. So the more time you spend in places like a closed space with just an HVAC or like a cassette AC with no fresh air ventilation, you're bound to feel nauseous, lethargic, all these other things, right? So again, to further build the context, what were the causes of pollution? So we use the sensors, and in the subsequent slides, I'm going to show you what the sensors looks like. But if I have to set the context, poor poor air quality already because of the construction. Further, we have industry fumes that are coming from the nearby factories. We're looking at PM 2.5 at 278 micrograms per meter cube. That's a very high number. So Dr. Roshni mentioned a number of 15. It's very far away from that figure. When you measure inside, it's not that much better. It just goes down to say maybe 260. The small filters that are attached in the VRV cassette is able to take out some out of it, but not a lot. So, it's still at 260 micrograms per meter cube. There is a buildup of CO2 because of people present inside, and we could see CO2 at 1500 ppm. We are also a manufacturing facility, so we have a soldering pollution also coming from the inside. So these were all what we assessed using the sensors that we have. Now, when we talk about what kind of solutions we want to put and what kind of thought process goes into solutions like these. So first we look at the kind of monitoring. So we have these monitoring systems set up every 1000 square feet of our space. It helps us in real time, not just to see what the air quality is like, but also helps us experiment into what different things impact, like how does a plant impact the air quality? How does it impact if I switch off the filter? What happens if I use a filter for too long? What is the right time of using the filter? So on and so forth. And similarly, outdoor air quality, we have one monitoring unit that is not, it's not one of the bigger CPCB approved products, but this is a product that we have worked with the Pollution Control Board as an alternative in a low cost sensor format. So, we are working actively at landfill sites. So these sensors are typically used at landfill sites to understand the generation of ozone, generation of formaldehyde, so on and so forth. So this is a setup we've used to assess what are the fumes coming out from the industry. And if we need more than just particle filtration, do we need filtration for chemicals as well? And in terms of the solutions inside, we are talking about, so if you can see on the top picture, we have used a VRV cassette system. The VRV cassette system is then aided, if you can see, there's a white grill. The white grill just below if you see just below at the behind the windows, this particular grill is where the fresh air is coming from. So the system is designed in a way where the temperature, humidity is taken care of by the cassette ACs, and that are providing the cool air at a regulated temperature. The MRT is solved by using the right kind of glazing for the windows. So that's all at the decision making side when we look into when we look into design the space. The fresh air is handled by a separate unit. Typically in foreign geographies like Europe, it's called as a dedicated outdoor air system, short for DOS. What we've developed here is a automated mini DOS system. So a mini DOS here means that it is designed specifically for spaces 2000 square feet and smaller. Generally, a dedicated outdoor air system in a building in Europe takes care of the entire building through a single setup. But in India, you have multi-tenant buildings. So the focus is a particular tenant or a particular office usage has a little bit of a higher amount of people. So therefore, I just need this for this 2000 square feet space or a 5000 square feet space. So we've built a few units. These units take care of a 2000 square feet open area space. So the picture below, it shows this white box, which is mounted onto the ceiling side, but it's a box that can be mounted almost anywhere. It's like a outdoor compressor. You can mount it on the wall, you can mount it on the floor, you can mount it on the ceiling. All it needs to do is take air from outside. So from one side, it is pulling air from outside. The white box that you see contains a 4-stage filtration unit. So you have a pre-filter that takes care of all your bigger dust particles. You have a fine filter that takes care of the fine dust that comes because of the effluents and the emissions from the factory. Then you have a HEPA grade filter, which takes care of the PM 2.5. Now, PM 2.5, people say a lot of PM 2.5 in the media, but let's put into perspective how small PM 2.5 is. The width of a human hair is 10 microns, which is the size of a PM 10 particle. Now, you imagine a particle that is 75% smaller than the width of a hair. That is PM 2.5. It is invisible. It will not be visible in air. The smoke that you see is typically PM 10, but the invisible pollution is the PM 2.5. So you need a HEPA filtration, an H11 grade filter. And finally, you have the 4th stage of filter, which is the activated carbon, which absorbs the ozone that is in the outdoor air. It absorbs the formaldehyde and the TVOCs that are in the outside air. So effectively, what happens is you have the system that is creating positive pressure inside and is filling it with clean, fresh air. So that's its job. So the cooling is taken care of by the cassette ACs. The outdoor unit is bringing clean, fresh air. And this kind of a system can be installed in any setup. Like even if you have a small office, 1000 square feet, or a big office up to 50,000 square feet, the combination in the engineering can be thought of in a way where the cooling can be given to the extremely efficient VRV systems. VRV are very efficient. So, you would want to use cooling with a VRV system, but the air quality can still be maintained and can still be measured and still be brought down to excellent levels. Now, certain decisions we took when we said we want to have a better environment quality. So one, air quality is one part of it, but environment quality is not just design decisions in terms of how I want things to look, but also design decisions as to what makes it easier to maintain. So there are certain, when we were working, there were certain dogmas that we were working with. And we have to point out that we are in Mumbai. It's a coastal region with very high humidities. In the month of summers right now, humidity goes as high as 80%. So false ceiling was something people kept saying that, why don't you put false ceiling? But false ceiling are good for places where there's dry heat, like a Hyderabad or maybe a Pune. Again, I'm not an expert, but I know for sure from my experience with data that coastal regions, your number one enemy for musky smell in coastal regions is the false ceiling. It gives space for fungal to grow. It gives space for damp areas. ACs generate a lot of heat. It's cooling you on the other side, but it's generating a lot of heat on the opposite side inside the false ceiling. And it is just the bedrock, foundation bed for a lot of microbial and bioaerosols to grow. It was a conscious decision for us that we do not want a false ceiling and instead we want to keep it open. So there are certain aesthetic challenges to it, but in the long run, it helps us clean and maintain a dry area and gives us a space where we don't have to maintain the mold again and again. The other thing we did was a lot of people said, if you want fresh air, why don't you go for an AHU based system? But AHU based systems are very inefficient in terms of their cost, because the cost is there's a lot of ducting involved. Again, the ducting has a lot of places it can get damaged or it can get blocked, causing a lot of issues. So if you really just want to add fresh air, there are other ways, like as we described, VRVs are extremely efficient, but a lot of designers or a lot of contractors would say that, okay, but VRVs say you will not get fresh air. How are you going to deal with that? So the setup that we designed here specifically was keeping in mind that we want to get VRV systems. They are efficient to a big extent, especially at a 6,000 square feet space. A VRV system does an excellent job. So it controls the temperature properly, and to deal with the air quality, we have additional engineering that supports a VRV system to add better air quality. And the last part is, it's a tenant space. Why should I invest so much in better air quality? I'm just improving the tenant space. But that is another dogma that we feel is present, that is because a lot of people feel that the infrastructure is permanent in nature and cannot be removed. So we designed the product in such a way specifically so that it is something that you can move as your area moves. It can scale as your area scales. It can move as you move from say a location A to location B. So you can use it 3 years for location A, but that asset continues to run for you. All you need to do is engineer it a little bit as per your new space, change the filters as per the new ambient conditions, and the same system is ready to go. That is also another reason why a lot of people don't go for the AHU, because if I have to just occupy space for 3 to 4 years and I might have to move, then let's just stick with the air that we are provided. But that is something that we advocate against. You don't have to stick with the air that you're provided. You can improve your air. It is possible to engineer a solution where you can get these ducts or get these systems to provide fresh air in your space. Now, what's the reality? Now I've given you all the background context, but what is actually the reality? The reality in pictures is in front of you. The outdoor conditions, as you can see right behind our office, you have this setup. We are not unique. This is not unique to myself. A lot of offices have this in their background. And it is not right to also say that, let's shut all this industry down. It's the lifeblood. But is it possible to give your employees good air quality in the face of these conditions? Yes. What does that good air quality look like? So at the third photo, new versus used filters. On the left-hand side, you see a brand new filter that you install on day 0. It's white with no pollution. What you see on the left is usage after 4.5 months of peak winter pollution. In that 4.5 months, this is the air that our office would have taken in their lungs if we didn't have uh, the right kind of systems. Now, it is invisible, right? This pollution is just visible right outside the chimney, but by the time it enters your space, it's invisible. So it's not very easy for people to realize the kind of air that they might be breathing, but these filters tell a complete picture. Typically, the monsoons in Mumbai is a very big relief for air quality because it comes down significantly. But the summers and winters are no different. It's just that winters are much more visible, but we make it visible all the time using our data for ourselves. And more importantly, these filters make it visible for everyone, that the kind of air that we might be breathing. Now, again, now we set up the context. Did we feel impact? Yes, we felt impact. Did our employees say that they feel better with the air? They use the words, we feel that the air is lighter. We feel that the air is fresher. And there are a lot of qualitative benefits that we can see from it. And the qualitative benefits not just include things like better air quality, better productivity, or better fresh air, but something as simple as absenteeism. Every office will have at some point or the other someone who comes in sick. An office with bad ventilation will make everyone sick, but an office with good ventilation isolates everyone from that sickness because it is diluted with the fresh air. So a sick person doesn't make the entire office sick. It reduces the amount of absenteeism, it improves the productivity, and it does not give you those bouts of extreme office sickness that sometimes people experience. Qualitatively, what did we see? We switched on the system. So this is a typical day, and this is what we say when we experiment in our office. It's a live situation where people are breathing this air and we are monitoring this air. We waited till 2:20 p.m. That is the time when our entire office is occupied. It is at steady state. People have had their lunch and office is at peak capacity. So if you see the graph on the bottom side, the bottom graph shows the carbon dioxide versus time. It is basically an understanding of what is the level of occupancy and therefore what is the amount of fresh air inside. So at the peak at 2:20 p.m., it reaches up to 1800 ppm, whereas the acceptable limits are close to 950 to 1050 ppm. It is at 1800 ppm. You switch on the system in 20 minutes, the CO2 comes down to almost 800 to 750 ppm, which is the acceptable limits for the air quality, right? So that is what the system is supposed to do. It is supposed to bring in fresh air, but the fresh air also comes with its set of pollutants, right? That is why it's critical to monitor the PM 2.5 as well. Now, the PM 2.5 is something that reaches up to 250 to 60 micrograms per meter cube. You switch on the system, it goes down. There are still waves, but eventually it settles down to single digit values, close to 3 to 5 micrograms per meter cube. So from 260 right down to 5. And the reason for that is because you have the HEPA filtration. Now, HEPA filtration, many people think that it is something that is required only in a pharmaceutical or a clean room or a hospital ICU. They're right. They're absolutely right. However, with the kind of ambient pollution you have out there, to even have breathable air inside, you will need a HEPA filtration. And the single digit proves that, the HEPA filtration is not just necessary, but also extremely effective in making sure that you're breathing clean air inside. Now, I will leave this as the last slide. We to what levels of air quality we could bring it down to. And the biggest question that people have when they look at air quality is that what is the cost? What is it going to cost me to bring this air quality down? And it's a fair question. So we have 77 people in our office. 77 people in our office for 3 years. If I have to give them fresh air for 3 years, the cost of clean air per person for a single day is 6 rupees, which is the cost of 1/2 cup of chai. So if I want to take care of my employees for 3 years and I want them to breathe clean air for 3 years, I can spend 6 rupees a day. And that's what I would urge everyone that I meet. I would say that if you want to take care of air quality, the cost is not that high. This is the cost and this is the result. So with that, I will I will I will close my presentation for today. And we just discuss and talk about some of the things specifically.
Thank you, Abhinav. And I think you should keep this screen on because
Sure.
these numbers are just mind-boggling, and people should know what it is. And
Yeah.
I think you're doing excellent work, and your presentation was also very good. And I think it's going to,
Right.
I hope, inspire a lot of people to do things that will save their employees or do things
Right.
for their people.
Right.
But at the same time, it makes me feel sad that what have we come to?
Yeah.
What kind of environment have we created in our cities and surroundings that we have to use filters and all sorts of things just to breathe good air?
Yeah.
We have come to that day, unfortunately. But I always say that empirical data is the proof that is the proof in the pudding, and design should be based on numbers. And so
Yeah.
you have done exactly that. And I think that design is no longer the domain of just architects or designers. It's a multidisciplinary field, and we
Absolutely.
do need the presence of engineers and scientists to help us, improve the environment inside. I know that we have also been talking about good quality lighting, so we will probably do that on another day, something that is called as human-centric lighting.
Absolutely.
But coming back to this, I just had one question about the carbon dioxide level. So I just probably missed something. How do you, like, when you showed the initial numbers outside, I think the numbers were pretty high of the carbon dioxide levels in your area, which
Yeah.
was, so I was just wondering is to what is that, so this 1500 is inside,
Inside.
and it's outside is 409, is it?
Yeah.
Okay, so outside is less and it increases inside because of people.
Yeah.
That's an amazing fact that people should notice. I have seen
Yes.
people who cramp their offices so damn full that you can smell even sweat in that place, which is really
Absolutely.
so poor. When you talk about bioaerosols and everything, one person gets sick, everybody can get sick also. But
Absolutely.
how do you address in your machine? You mentioned about various filters, but I probably missed. How do you address the CO2 issue?
So, okay, yeah. So the CO2 outside at 400 is much lower, but again, this is something that has, steadily increased because of climate change. It used to be 350 back in 2013, but that is the outside CO2 because of the heating and everything. Inside, basically, CO2 is generally because of lack of fresh air. So there are either you're in a leased out space, and this leased out space is giving limited amount of fresh air. So, say for example, per person, you will need say 25 CFM of fresh air, right? And if the tenant space is provided by 800 CFM of fresh air, so you're talking about maybe say maximum of 40 people, right? So now for something like that, like it will be some kind of a figure. So if you have more people than that, the CO2 will increase. So the idea is to get fresh air.
Okay.
It's the typical thing when you sit inside a car and you close all the windows, you feel like it's feeling suffocating. Let's open the windows. What we can't do is we can't open the windows because there's an HVAC going on, and B is that there's this whole pollution coming out, right? So this solution that we're talking about here, what it does is it provides the fresh air. It's equivalent of opening the window, but the air that is coming through the window is forced through four filters, and now that clean air is then given inside. So it's like opening the window, but you're getting clean air passed through this box, and then it is being cooled with the HVAC system, but with the ventilation and everything. So what happens here qualitatively, if you see, so in this graph, right? So if I look at this graph, so the bottom graph, what happens is you're looking at 1800 ppm of CO2. That's a peak. So now what happens is you
That
have this like
happens
fresh.
as people come over and more people join. I guess the office is
Exactly.
completely full, and things like that, right?
Yeah. So clear. So you can see that there is a first peak that reaches up to say like say 12 or something, 12:30. And at said 12:30, there's some more people have started to come in. So people start coming in at 10, slowly, steadily the office fills, and there are some people who come late. So the people who come later at 12:31, you can see at around 2, you will hit the maximum. So that's where we wanted to see what is the steady state on the upper side. So that is 1800 ppm. At 1800 ppm, the entire day would be running like this, and then as people leave, it would sort of go away. Now, when you switch on the system, it is pumping in fresh air from the outside, right? And what it does that it displaces all of this. So CO2 being heavier than air will settle down. It will keep pumping in air, and this air will then go through the leakages, through the nooks and crannies of your office. So it keeps pumping in the fresh air, and that is what helps in reducing the CO2 drastically. So once what happens is once the CO2 comes down, it reaches a steady state. It's like some CO2 is being generated by people, but you keep replacing it with that much amount of fresh air. Now, if it were completely displaced, then you would see it to be close to 400 ppm of CO2. But this area is occupied by almost 25-30 people. So to do that would require a lot of fresh air, which doesn't make sense. So you just want to bring enough that matches the standard. The standard says 800. Okay, we'll bring it up to 800. You can bring it up to 600 as well, but it's more energy, more electricity. So, but we can bring it up to 800. So that's what we did, just enough so that it reaches up to 800. And the moment it reaches 800, we cut it off. So it just maintains at that particular level. So that's how we would deal with the issue of CO2.
Fantastic. So I would like to, end with the IAQ challenge with the instrument that you have. But before that, I just want to, since you are an innovator and you are into, designing these kind of instruments and, new kind of things, one of the things I always feel is the time before the interiors are completed, the workers. So they are the ones who actually face a lot of dust and all sorts of pollution. In fact, they get completely exposed to VOCs.
Yes.
And this is a very sad situation. I mean, also the noise is a factor, big factor in interiors. Some noise is always going on when interiors is on. So these are issues that need to be addressed. And I was just wondering if you have any thoughts on the time when the interiors is going on, if something can be done.
Absolutely. I think protective equipments is something that, so that there's a thing that, we understand the need for the protective equipment. In my office itself, when we do soldering, it gets a lot of smoke out. There's particulate matter. We do everything to keep the air quality fine, but when the solder is out, it's going to come out directly in your eye. Similarly, if someone is doing an interior work, woodworking, you have the granite working, you have the drilling going on. So imagine you are if someone's having some kind of work happening in the building or some constructions happening outside, and you're facing the drilling, you're finding the drilling to be distractive, and it gives you headache. Imagine what's going through the person who's actually next to the drill. So I think critically the first thing being the personal protective equipment, because the noise is something that you cannot eliminate, unfortunately, with the kind of work it is. The pollution and noise cannot be eliminated, but equipment such as like goggles, I think goggles are something that I think is extremely important. We should have some or the other kind of masking that can help, or helmet kind of a stuff that at least protects them from the bigger stuff. Maybe we don't want to go for an N95, but some kind of masking is critical. Your mufflers are extremely important, not just because, again, noise is definitely one thing, but earmuffs like this can help them also with like particulate matter that can sort of, and a lot of particulate matter is generated. Let's just be honest, like it's like if you're gonna grind something, or you're gonna be drilling something, or you're be cutting something, it creates a lot of dust. And the people should be protected, for sure. They should be protected, and the first layer of protection always comes from these equipments, the PPEs, that were very common in COVID. There are variants of that can be used even for day-to-day construction, and I think we should have much more of that. That should actually become a norm, I feel, but I think there is some way to go for that to happen.
Great. I hope that you can start thinking about these people and maybe come up with some solutions. And of course,
Absolutely.
there are norms that are required, but we know that most contractors in interiors are not liable for anything, and they are
Yeah,
not, there are no norms and regulations for them yet. So with that, I think I would like to close our session, because I don't want to make a long session. We can always do it again if there is demand from
absolutely.
people. And what I would like to put forth at the end is, if you can show that instrument of yours, one which
Sure.
takes the readings. So uh, if any one of you watching this program would like to get your interiors tested and find out what is your indoor environment quality, we have this equipment, and we have people who can come and measure, take this instrument to your place and actually measure the levels of indoor air quality, like VOCs and
Yeah.
CO2 as well. Does it measure CO2?
Yes, it does.
Yes, yeah,
It does.
and temperature, humidity, these parameters. So if you feel that way, please do feel free to contact us, and we'll be there to help you. It will be absolutely free of charge. We'll try and see what can be done as well to
Absolutely.
improve your situation. So
Absolutely.
with that, thank you, Abhinav.
Thank you
Thank you
so
for
much,
the
Dr.
session,
Roshni.
and looking forward to working with you.
Thank you so much, Dr.
Thank
Roshni.
you.
Thank you.
Bye-bye.
Bye-bye.
Bye.